The weather and climate often cause concern and curiosity, but understanding the facts behind the phenomena can be a challenge. We're here to help. From the University of Illinois Urbana-Champaign and Illinois Public Media, welcome to Weather Realness, a weekly podcast about the skies above Illinois and the world.
I'm your host, Trent Ford, the Illinois State climatologist with the Prairie Research Institute here at the University of Illinois. When heavy rain falls in central Illinois, it can quickly overwhelm some drainage systems. For years, this was a problem for the Garden Hills neighborhood, where thousands of people live in northern Champaign near Interstate 74. Listen to this 2021 report from WCIA-TV.
A family had to be rescued from their car near the intersection of Prospect and Bradley Avenues. Samantha Carter says while today's rain was heavy, Garden Hills was flooding like this almost every time it rains.
It is definitely a big headache, and it's an inconvenience. Every time the clouds gather, it's going to be an issue out here when it rains.
Flooding issues in Garden Hills and other low-lying communities have the potential for becoming worse as rainfall intensifies due to climate change. The city of Champaign is addressing these issues through the Garden Hills Neighborhood Drainage Project. University of Illinois journalism student Lyric Roy is reporting from our host station, Illinois Public Media, this summer. She recently toured Garden Hills, which is receiving some of the infrastructure improvements, and she joins me now. Welcome, Lyric.
Hi.
So, can you tell us what's going on in Garden Hills?
Yeah, so there was a project to mitigate flooding in the area, and there were 3 phases to this project. So the first phase was the city of Champaign acquiring 47 homes and properties across Hedge Road, from Mattis Avenue to Hedge Court, and 1 north of the railroad tracks along Hedge Road. And all of those residents were relocated and compensated for their time, and that phase was completed in July of 2021. The second phase was construction of the 2 stormwater basins on either side of Hedge Park. This mitigates most of the potential flooding problems, and each basin can hold up to the equivalent of 110 feet of water over a football field. These improvements also include Hedge Park, which is between both of the basins, and there are pipes under the park to equalize both of them. Construction on this phase started in November of 2023 and was completed this past Monday, on June 8th. The third phase is north of the railroad tracks near the Garden Hills Academy. This is where large underground storm sewer pipes collect water and bring it to the basins to be held temporarily. And those basins will release water slowly into the Copper Slough Channel by Parkland College. This phase is still in progress and is expected to be finished by the fall of this year.
Yeah, so pretty extensive upgrades in infrastructure. Can you give us a little bit of a brief history about Garden Hills and why infrastructure like these drainage systems either weren't put in place in the first place or were maybe underdeveloped for the rainfall that we're receiving these days?
Yeah, so I asked the same question to one of the project managers, Alex Naj, and he said that the area was developed in Champaign County in the late 50s. At the time, it wasn't a part of the city. The county had less stringent regulations than what we have now, so the infrastructure that was built was substandard by today's standards. This meant that when there was heavy rain, there was a lot of flooding. These requirements also didn't require sidewalks or street lighting, so there just wasn't any of those put in place. It was just simply a different standard than we have today.
And since you spent some time in the neighborhood, how are residents responding? Is this overall positive? Is it it's about time, or what's the overall response?
Yeah, it seems like residents are really happy about this. Project managers and city planners told me that the response has been really positive. Obviously, no one likes construction preventing them from driving or walking through their neighborhood, but the improvements really speak for themselves. There's now a number of recreation spaces for residents, benches to overlook the water basins, there's Hedge Park, there's sitting areas, and there's walking paths around both of the basins for those residents.
Yeah, well, thank you very much, Lyric, for joining us and describing what's going on there in Garden Hills.
Thank you.
So that was Lyric Roy, a student journalist in the Illinois Public Media newsroom who toured Garden Hills, where the city of Champaign has invested millions of dollars in drainage and other infrastructure improvements to deal with flooding. You're listening to Weather Realness, the podcast about weather and climate from the University of Illinois Urbana-Champaign Department of Climate, Meteorology, and Atmospheric Sciences, and Illinois Public Media. I'm Illinois State climatologist Trent Ford, and today we're talking about how flooding and intense rainfall can overwhelm communities. Joining us now, Dr. Deanna Hentz, Associate Professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign, and Dr. Ashlyn Stillwell, Associate Professor of Civil and Environmental Engineering at the University of Illinois here in Urbana-Champaign. Thanks for joining us.
Thank you for having me.
Thank you.
So, Deanna, let's start with you. We talk about Garden Hills and its history of chronic flooding, and Lyric kind of took us through that. What types of weather patterns tend to produce this kind of urban flooding in neighborhoods like this? And why are these particular communities so vulnerable to these types of weather events?
Well, to answer the first question, there's a few different kinds of precipitation patterns that can really lead to a couple different kinds of flooding. So the first, which would create more what you would consider your flash flooding, would be these very intense downpours, say from a very strong thunderstorm. These will put out a ton of rain in a very, very short amount of time, which can just temporarily overwhelm the ability for the storm sewers to carry that water away. And this is where you might see a lot of ponding on streets, or the temporary flooding of a field before that water has a chance to absorb or to run off into the storm system. The other kind that you can see, though, are more longer duration events where maybe the rain rate isn't super high, but it can happen over a long period of time, say that over the course of hours or even days. And this is especially true if you already have had a lot of wet weather prior to the event. And so maybe the water doesn't have as many places to go. So if you're experiencing already very soggy soils, receiving a lot of rainfall, and then the soil's already saturated, and maybe the sewer system's already, decently full. And so then you can have a increased ponding or various other things that can develop more over time. So the types of weather patterns that really are associated with that, again, can range from your very intense thunderstorms to something like what we call a squall line, or a really big thunderstorm system called a mesoscale convective system. These can come with very high rainfalls followed by a longer period of more moderate rainfall over time. Now, to the second question of why are these communities so vulnerable? There are some communities that it can be a number of factors. It can be anything from the local drainage, like is the community in a bit more of a low-lying area, or a place that maybe once upon a time used to be very marshy. So it's maybe in a bit of a depression. It could be because there's a lot of impermeable surfaces, that meaning like roads, concrete, asphalt, these kinds of things where the water doesn't necessarily cannot soak into the soil. And it can also be a response of how much capacity the sewer system has to handle that storm runoff. All of those things can contribute to the vulnerability of a particular community in a given place.
Yeah, and something you kind of mentioned briefly was that, thinking about the disproportionate impact of hazards like flooding. Going back to Garden Hills here in Champaign, that neighborhood is comprised about a third of Black and Latino residents. Is that kind of pattern of demographic differences between neighborhoods that flood frequently and neighborhoods that don't? Has that been found in other communities outside of Champaign-Urbana? And if so, why is that pattern concerning?
Yeah, a lot of research has really shown that some of these, especially when it comes to flooding, do tend to disproportionately impact communities that are marginalized in our society in some way, be it economically, ethnically, racially, etc. And that does have a tendency, especially to impact Black and Latino communities, where that economic marginalization and racial and ethnic considerations sometimes frequently intersect. These are the result of different building practices and policies that have affected American communities throughout our country. And that has frequently put sometimes some of the most economically vulnerable members of our society in harm's way of some of these hazards the most frequently. And so it's concerning when this population can be exposed to these hazards over and over again and may not have the financial resources to be able to cope with it.
Yeah. Well, let's bring in Dr. Stillwell here. Ashlyn, a drainage study in 2016 found that undersized storm sewer pipes were one of the main causes of flooding in Garden Hills. Uh, what does it mean for storm sewer pipes to be undersized, and how can that become a problem? And is that problem unique to Champaign?
For a storm sewer system to be undersized, it means that the sewer pipes themselves have a diameter that is not sufficient for the flow that is coming into those pipes. And like you heard earlier from Lyric's reporting, that is largely because of a change in the policies around building in the Garden Hills neighborhood. It's not that we did bad engineering when we first designed and sized those pipes, but we were designing and sizing for a different standard. And the amount of flow that comes into those storm sewer pipes is, as Deanna mentioned, a function of the rainfall and also a function of the land cover. And so this, unfortunately, is a challenge that exists in many places where we have changing rainfall patterns, often intensifying rainfall patterns, and we have changes in land use such that there's more impervious surface, creating more runoff, more stormwater from those rainfall events. And those pipes that we designed decades ago for a particular flow are now not big enough.
Yeah, it's so another issue with this storm sewer system is sounds like is drainage paths is something that Lyric also mentioned at the beginning. And the study back in 2016 also mentioned the lack of proper emergency overland flow paths to push that stormwater towards Copper Slough. Can you describe a little bit about the importance of those drainage paths and why in this particular case in Garden Hills contributing to the flooding issue?
Drainage paths are really important because that's how water is going to move from where the rain falls to where it is flowing downstream. And water is always going to flow downhill. But when we change the development of the land, we build out homes, we build out industrial facilities, commercial facilities, and roadways and all of that infrastructure, we're often regrading the land and we are changing the soil properties. And so that regrading means that we've got different topological surfaces and have drainage going in different directions than we might have had pre-development. And the changes in soil can also affect how quickly water infiltrates into the soil versus how quickly it runs off and then needs a place to go.
If you're just joining us, this is Weather Realness, the podcast about weather and climate from Illinois Public Media and the University of Illinois Urbana-Champaign. I'm Trent Ford, a state climatologist with the Prairie Research Institute. Today we're talking about flooding issues largely and specifically in the Garden Hills area in Champaign with Dr. Deanna Hentz, Associate Professor at the Department of Climate, Meteorology, and Atmospheric Sciences here at the U of I, and Dr. Ashlyn Stillwell, Associate Professor of Civil and Environmental Engineering at the University of Illinois. So, Deanna, what are some of the biggest environmental impacts of flooding? I mean, obviously, it's not fun having, 3, 4, 5 inches of water or more in your basement. But what are some of the environmental or health impacts we see from flooding in places like Garden Hills?
Yeah, I think one thing that's important to keep in mind is that there are, when we think about flooding, we think about maybe inches or feet of water in somebody's home, but there's this other kind of flooding, which is, I think, sometimes referred to as a nuisance flooding, such as a basement flooding or a sewer line backing up into someone's home. Besides those things being kind of just gross to deal with, there's numerous problems that can stem from that. One, that people's property is getting damaged. So that could be whatever belongings were impacted by that flooding, but also the home itself. That water can infiltrate into walls. It can infiltrate into basements, cause mold issues, and that can lead to different health impacts over time. And then also, of course, the water itself, especially if it's coming from stormwater runoff or sewer, there's going to be contaminants within that, right? That have to then be removed or cleaned for, from those belongings or from that home. And so all of that can cause a lot of financial stress and possible health impacts as well.
Yeah, it seems like uh, so maybe similar to other types of hazards, but maybe even more so with flooding. The it seems like the environmental impacts can really linger or lag after the actual floodwaters recede. That's what you're saying. So, Ashland, to solve this decades of flooding, the city of Champaign has developed a detention basin along Hedge Road. Can you give us kind of an engineering perspective about what is a detention basin and how does it work?
A detention basin is an engineered storage impoundment that is designed for a particular flow of incoming stormwater. And you could think of that as an engineered pond for a specific purpose. Those detention basins have the advantage of collecting water from a storm sewer and slowing down the flow of that water by storing it in an intentional storage capacity of a pond and allowing for improvements in water quality before it is then discharged downstream at a lower flow and an improved water quality.
And why is slowing that flow of water, as opposed to just getting it out, for example, why is that a more effective engineering strategy?
That's an excellent question because our kind of traditional engineering approach was get the water out as quickly as possible because we often saw stormwater as a nuisance. And when we get the water out as quickly as possible, water can have very peaky flows to it. It can be a lot of flow in a short amount of time, and that can lead to a lot of soil erosion and picking up anything in its path, whether that's animal feces or heavy metals from vehicles, soil and nutrients, excess fertilizers from lawns. If we treat that stormwater like a nuisance and just shift it away as quickly as possible, that takes all of those distributed resources and gets rid of them as a waste, but it causes much larger problems downstream. And almost all of us are downstream of someone. And so when we implement those upstream solutions to slow the flow of water, allow it to infiltrate, and use it as a resource, which it is, then we can reap those benefits and also mitigate those downstream impacts that come from water quality and water quantity. When we slow water down, we significantly reduce the risk of flash flooding, which at the extreme can be intense loss of life.
Ashland, can projects like detention basins completely eliminate flooding? Is it one of many solutions or the solution? Are there other types of solutions besides detention basins that communities have used to reduce their flooding risk?
Unfortunately, no solution will completely eliminate flooding. Water will always find a way. And what we do as engineers and designers and planners is to implement a suite of solutions that include detention basins and storm sewer systems and also other installations of green stormwater infrastructure, for example, to manage that storm runoff where it falls. Things like rain gardens and permeable pavement can help shave off some of that runoff and infiltrate it where it falls. As rain falls on those surfaces, they infiltrate water instead of contributing to runoff downstream. And we've seen examples locally where detention basins don't fix all flooding problems, but they make a significant difference. I have seen photos of Campus Town before the reworking and renovation of Boneyard Creek and installation of the detention basin in Campustown. And students would take kayaks and canoes down Green Street because it would flood so deeply with stormwater that they could take a kayak down Green Street. And now we don't see that happening, but we also see very much a revitalization of that part of the city for student life and students wanting to live in Campustown, where previously that was not really a place that was conducive to significant, intense residential living because of flooding problems. So it can work. Nothing, though, will prevent all flooding everywhere all the time. We have to learn to live with water and to also design infrastructure that is safe to flood. That's one of the great aspects of this Garden Hills project, is that it's incorporating water as a resource and as an amenity. And by introducing those walking paths and other recreational amenities in the event of extreme heavy rainfall and intense flooding, that infrastructure is safe to flood, because we would much rather flood a walking path than flood many homes.
If you're just tuning in, you're listening to Weather Realness, the weekly podcast about weather and climate. Today, we're talking with Dr. Deanna Hentz, Associate Professor at the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign, and Dr. Ashlyn Stillwell, Associate Professor of Civil and Environmental Engineering at the University of Illinois Urbana-Champaign. Switching to some flood safety to kind of wrap things up. Now, Deanna, what should people do when a flash flood warning is issued? And thinking about differences with people who may be in a building, their home or workplace, versus people who are driving or out and about.
Yeah, so when a flash flood warning is issued, especially one of the most vulnerable places that you can be is in a vehicle. Paying attention to, rising water on roadways, not driving through flooded roadways is probably one of the biggest things that anyone can do to preserve their safety. Paying attention to, where the location of the flash flood warning is. And especially if you happen to be near a waterway that is experiencing a flash flood, making sure to seek higher ground as quickly as possible, because the nasty thing about flash floods is that they can happen very quickly, and frequently the water can be moving very swiftly. And depending on the circumstances, it could be easily enough to knock someone off their feet. So just being very aware of especially if you are out and about, paying attention to the water levels, and removing yourself from an area if the water is starting to rise.
Yeah, and on that topic, for both of you, we saw photos, or I saw photos of the one of many vehicle rescues from the flooding in Danville recently, and then there have been a couple of others in Springfield.
The flooding also caused damage through the area after parts of roads were swept away and cars got stuck in running water.
The Vermilion County Sheriff's Department says 9 people were rescued Saturday night and 4 others on Sunday.
What are, so that idea of turn around, don't drown, it's good in theory, but what should people be thinking of when they are driving and they do see water covering the road? I mean, what is, how does that decision get made of, yeah, I can make it through, versus maybe it's not so good, and how should people be thinking about that?
Yeah, one thing that's really important to keep in mind is that it only takes a few inches of water to be able to lift and potentially move a vehicle. And so, as Ashlyn said earlier, you cannot deny the power of water. It is one of the most powerful out there in the world. And so it can sometimes be difficult to tell exactly how deep the water is in a particular spot, especially if you're not familiar with the area. But I would say that if in doubt, turn around, because one other thing that is a underappreciated risk is not only the depth of the water picking up and carrying the vehicle, but also that the water could be undermining the roadbed itself. And so there have been instances where the road has actually washed away, from above the water surface. And so it's generally a good idea that if you're ever in doubt about it, just a diversion will probably be a better bet than taking the risk.
Yeah, well, thanks to both of you for this really rich discussion. I really appreciate it. And so thank you for joining us, both Deanna and Ashlyn.
Yeah, thanks for having me. This was nice.
Thank you for the invitation.
So we've been talking with Dr. Deanna Hens, Associate Professor at the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign, and Dr. Ashlyn Stillwell, Associate Professor of Civil and Environmental Engineering at the University of Illinois here in Urbana-Champaign. And I'm Trent Ford, the State Climatologist with the Prairie Research Institute. Thanks for joining us on Weather Realness. Coming up next, summer weather is definitely here, and we'll be talking about how to stay safe under the extreme heat. Do you have a weather or climate question you want us to answer? Leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu.